So let's just continue with SQL. So I've given a summary of what the mapping between SQL and relational algebra with the select statement out here. And before we start, I just want to mention that the quiz on Wednesday is not going to cover SQL. It'll just be on relational algebra because I haven't had a chance to test you on join yet. So for the first two quizzes, the database you're looking at was tiny. So with every question, I was also showing the database. So this next assignment onwards, the database is going to be slightly larger. I have to put in multiple tables and it'll have more data. And the database and your question will not all fit on one screen. So when the quizzes are in class, it's not a problem because I give the students the database on a separate sheet of paper and then they have the quiz. So they can look at the sheet, they can draw on the sheet, they can do anything. But here, I don't have that option. So I'm still not sure how to address it, but I think that most probably tomorrow I'm going to put up the database instance for the quiz. I'm going to put it up tomorrow evening on the Canvas webpage, and you should download it and print it out. So when you take the quiz, you can have that sheet next to you while taking the quiz. I will also have it, actually I won't because it's so large. There's no point putting it next to each question because you'll just be scrolling back and forth. So before taking the quiz, you should download that database instance and print it out. You'll need it for the quiz. So do you have any questions in general before I start with today's lecture? Okay, so let's look at the next query. I'm just going to continue with SQL. So list the last name So list the last name of employees in Department 5 who work more than 10 hours and less than 20 hours on product X. So I would like you to try this out. You can use the between for the hours. If it's greater than equal to 10 and less than equal to 20, you can leave it that way. So please try out this query. So what are the tables that you have to access in order to answer this query? So anyone can answer. What tables have you put down in your query?
Project works on and employee.
Yes. So we have. So the important thing is to make sure you get all the join conditions also there. So, so we have. Okay, so this is the join between employee and works on. And then you have to join works on and project. So you'll have to use P number for that. Okay, so you can do this query. I mean, this is one answer to this query. You could do it in different ways, but this is, the most straightforward manner of doing it. And like I mentioned, it doesn't matter which order you put down your answers. I mean, you can put, you can have the join condition later. You can have, so this is the join here. This is the join here. And then all the sigma select conditions. Um, so, um, so if you don't have questions, I mean, I'm just going to keep continuing. So I want to show different features that you can have in SQL that we didn't have in relational algebra, the tool at least. I mean, the tool is built on SQL. So pretty much anything, if you build the feature in that tool, you could have had it. But so I'm going to show a few other features that are there in the in SQL. So the next one is that so far all the outputs we have been getting are not in any particular order. If you want to order the output, you can use the order by um, order by operator. So for example, let's look at this next query. Select department name and first name from department employee. Where? Okay, so I'm selecting the department name and the first name of the employee who works in that particular department. So I'm just listing that out. But suppose I want the output should be ordered by department number, and within department number by first name, you can do that. So so you can say order by, and so department name, first name. So the output for this particular query from the sample database, the output is going to be so we have so the first one is admin, and then you have all the names under admin. Jennifer, and then we have headquarters. And in headquarters, we have James. And then we have in research, we have the rest. We have Frank. Okay, so the output is ordered by department name, and within department name, it's ordered by first name. And the default ordering is ascending. If you look at it, it's all ascending. So that's the thing, is that the default ordering is ascending. But you can change that. So let's say that instead of doing this, I wanted to say order by, say, department name, and I want to do department name descending. You can write that next to it. I think it's DSC descending. And then maybe the first name I want to do ascending. So I can just say ASC. So in this case, it will order by department name descending and first name ascending. So so it's a pretty useful feature, but because it's a lot easier to read your output and understand your output if it's ordered by some attribute in the output, and typically the attribute is the key. Um, so this was a select statement, and like I mentioned earlier, that there are also statements that will allow you to modify the database itself. So modify the data in the database. I mean, so right now I'm talking about the DML statement. So and you've seen some of them. If you looked at the lab, you've seen, or even in your relational algebra, if you looked in the .ra file, those are all SQL statements in there. And you have, in order to insert new rows, how to delete rows, and how to update rows. So those are all commands by which you can modify the database. So there's the insert, the delete, and the update. So the insert command, you can say insert into employee, and then you can write down the values you want to insert. So for example, when you are doing your assignment, if you want to insert values into your database, just go to the RA file and insert a row in. So you can say insert John. Okay, so when you insert the order in which you insert these attributes has to be the same order by which they were defined in the database. So let me just, I'll just put up a different thing. Okay, I think out here we have the definition of the database. So if you look in the employee, of course, I haven't, you have first name followed by middle initial, then the last name, then the social security number. So you have to use that very same ordering that is used when you define the database. Actually, I have the definition. I mean, here I'm just drawing it, but I do have the definition. Just one second. Let me just pull it up. Okay, so this is the definition. Oh, yes. So this is the definition of the in the schema. This is the way the employee table is defined. So you have to put it in exactly that same order out here. So if you want to change the ordering, then you have to mention that. So So this is the ordering that is there when you do the create table. So it's in the same ordering. But if you want to change that ordering, then you'll have to do and then if you want, you can write down which order you want it. So instead, suppose I want to enter it in the form of first name, last name, then I want to put down the department number and so on. So then you can enter values in a different order. So like I mentioned, the attribute ordering does matter. So that's the insert option. And so the next, if you want to delete, is okay. So this will delete the row with all the rows where the last name is equal to Smith. If you just wrote down delete from employee, so be careful when you do something like this because it'll delete all the rows from the table. So you have to be careful with something like this. Um, so that's the delete. So it's pretty straightforward. So next, let's look at update. So we have okay, so in this case, it'll set the project name. It'll change the project name to product YYY, where the P number is equal to 3. So again, the next one, let's take a look. I didn't pull up, okay, and projects. So we have D number. Okay, so this next one, this update project, set P name is equal to product YYY and D number is equal to 3, where P number is equal to 3. This one actually will not go through. It'll give me an error for the sample database. So can anyone tell me why it would give me an error? And this is for the sample database. And, I just, maybe I should pull the sample database. Okay, so this is the sample database. So for this one, if I gave this command, it would give me an error.
D number is different.
Yes, it's different, but why would that give me an error? Because I mean, that's the main difference between this one and the previous update. I'm changing D number to 3, but why would changing D number to 3 give me an error? It has to do with D number, but can anyone, so this is the database. Yeah, go ahead.
I'm guessing that D number is a foreign key and it's looking in department locations where D number is probably the primary key and it doesn't exist. So because there's no primary key 3 in department locations, does that make sense?
Yes, and so you're using words that I haven't really used before. I mean, the primary part, yes, but not foreign keys. But I know what you said is exactly the right answer, but I just wanted to show, that's why I pulled this up on the left-hand side. So that's the thing is, the simple answer is that in the department table, there is no D number of 3 in the department table. So this is something that I'll be talking about in a lot more detail later when I talk about data definition language, but I wanted to bring this up here because you are going to be using SQL in your, starting with assignment 4, you're going to be doing SQL. So I think you should kind of know a little bit on the DDL and also because that's what you're going to be defining the company database and uploading stuff. So if you look at, let's look at employee. So the employee is saying stuff like primary key, social security number, and then it says foreign key, social supervisor, social security number is going up to SSN. Then it says foreign key D number, references department D number. Okay, so now let's go up here to this diagram. Now, if you look at this diagram, there are some attributes that are underlined. Okay, so the attributes that are underlined are the key. Okay, and so now because you're hearing the word primary key and foreign key, I just want to say that this is the primary key. All what is underlined is the key of this table. So for department location, the key is both the attributes, D number plus D location, because just D number by itself is not unique. You have to combine D number and D location to make a row unique. So for project, it's P number. For works on, it's employee social security number plus P number. And for dependent, it's employee social security number plus a dependent name. So that's the primary key. But now if you look out here, you also see these arrows. So let's look at, so the arrows that go up to D number. So you see that this, okay, this D number from here goes to D number, but then this D number out here in project is going to this D number out here. So let me see if I have project. So if you look at the project table out here, it says primary key P number. Okay, it also says unique P name. So one of the things I mentioned early on in the lecture was that a table might have multiple keys. So one key you choose as the primary key, and that is done by the database designer. They decide that, okay, this P number is going to be the primary key. But what it also means when it says unique is that P name is a candidate key. So because it is unique, so you can identify the every tuple, every row has a unique P name. So this is a candidate key out here. So this one's a candidate key. Let me just. And then it says foreign key D number, that this one references department D number. So whatever it's referencing, this has to be the primary key in department D number. Okay, so, and this is the foreign key. So what happens, it means that if I change D number to 3 out here, this is what I've done. I'm not able to switch to the right. Okay, I have changed this D number to 3, but there is no 3 in the department table. In the department table, you only have department number 1, 5, and 4. We don't have a department number 3. So if you update project and you update D number to 3, then because there is no 3 in the department table, it'll flag an error. So that's what's happening. And this is just an intuitive. I will be doing foreign keys and primary keys in a lot more detail later. But I hope all of you kind of intuitively understood why it gave you an error. If you haven't, please ask me, because so that's the thing, so the primary keys, so wherever you have all these arrows going up, these are all foreign keys out here. These are foreign keys, and you have, there are so many so even, so within a row, super social security number goes here. Then you have ESSN, and then you have project number here going to this P number out here. So that means you can never have a project number in WorksOn that does not exist in project. I mean, every project number you put out here must exist out here. So, yeah, go ahead.
You might answer this later on, but does a foreign key always have to refer to a primary key?
Yes, in MySQL, yes, it
Okay.
has to refer to a primary key. So there might be other databases where it could go to candidate keys or something, but not in MySQL. It has to be a primary key. So so then you also have so it's actually really nice. The database takes care of it. So if by mistake, if you do so maybe this was a mistake out here, where maybe the person who typed this update command actually made a mistake. So luckily the database will will immediately flag an error. So that also comes from, for example, if you try to delete from employee, for example, and you can try it, try it on that lab. When you have the lab, try a delete from employee, and you'll find that you can't delete the employee table. The reason you can't delete an employee table is because there are so many tables that are, that have a pointing to the employee table as a foreign key. So if you delete the employee table, for example, what will happen to all the other tables? There are data in the other tables that are pointing to this table. So if you try to delete the employee table, it's going to not allow you to do it. If you try to delete the department table, it won't allow you. The only tables that you could delete without any issue is department location, because it doesn't have any arrow going in. And you could delete, yes, you could delete the WorksOn, no arrows going in there. And you could delete dependent, no arrows going up there. So these are all tables where there are no other tables pointing to it as a foreign key. So you could delete those. But if you do a delete from employee, it'll flag an error. Similarly, if you delete or update something in one table that's affecting another table, the database will flag it. So this actually all comes under constraints, which I'll be teaching you much later in the semester, most probably in the second half of the semester, or definitely not right now. But I just wanted you to know that. So when you if you find that you're doing some update command that is syntactically correct, but it's still not working, the reason it's not working is because it is violating some constraint. And so these are all called foreign key constraints. So it will be violating that. So this was just, just wanted to give you a short thing so that, if you get an error, you understand why you're getting an error. So. Okay, so then let me just continue. So the next one is you can rename a table. So for example, the employee table, if you want to just call it emp, so you can rename to emp. And a rename is a permanent rename. So next time you log in, it's just going to be there. So this is it's still going to be there. So just as long as you are aware of that. Okay, so Okay, so let me just do a few other queries now. I just wanted to, so this was just a sidebar. I wanted to just do some of these insert, delete, and the update and the rename. Okay, so again, I want to just continue with the select and a few other features of select. So list the first name of employee has e-name. So you want to list the first name of employee has e-name and the first name of employee supervisor has S name. If the supervisor's last name is Wong or Bog. Okay, so I mean, this is, I've done similar queries to this, so I'm not going to ask you to try this out. So I'm just going to write this down, the answer for this. So you want to list the first name of employee has E name and the first name of employee supervisor has S name. So I'm not sure if I've done how to rename attributes. I've shown you how to rename tables in the last lecture, but I didn't do renaming of attributes. So let me write down this query and I'll show you how to rename an attribute. So this would be select. So in this case, I have to rename the table. So let me just do the next from employee E. So this I did in the last class, how to rename a table. Employee S, and you don't have to write employee has E and employee has S. You can just write employee E and employee S. So select E dot first name. And then to rename it, you can write as E name. And then as S name. And then you can write the rest. So we have okay, so that's how you rename an attribute name. And again, just like the old case, you could also have written it down as E dot F name, and you don't have to write as, you can just say E name. So this will work too. You don't have to put that down. Okay, so that's how you rename your attributes. So here I also want to show you another way of doing this query. And so this is where I'm going to show you the union operator. So remember we did union for relational algebra, so you understand how union works. So, but I haven't shown you how union works in SQL. I mean, the principle is the same, so I haven't shown you the syntax of SQL, how to use the union. So it works exactly like the way it does in relational algebra. So let's look at the union command. So I'm going to do this above the same query using union. So we have Okay, so you write the first one and then you write the union in between this. So we have, and then you do the next one. You might have to put parentheses. I'm not exact. I don't remember whether you require to, I don't remember whether you need to do this or not. So if you do get an error when you try it out, just put that in there. But for now, I'm just going to leave it off. And then you have, okay, so you could also do it like this. So both of them will work fine. So the union is very straightforward. There's really, nothing more for me to say on this one. And so both those queries are identical. You'll get the same result. So I want to show you a few other features of SQL. So let's look at this next query. I just want to bring the company database back. Okay, just want to bring that. So list all employees. Okay, so you want to list, so this is where you're looking at the address, but you're not looking at the entire address. You're looking only at a substring of the address. So if you want to list all these employees, then you can do that. And then, so you can use like, and then you can say percentage. So what the percentage does is that it matches 0 or more characters. So you can, you can match substrings within a field, or so the next query. List all employees born in 1960. So you can. So you can use like, and then out. Let's see. And then you can put the rest of the, if you want to match only one character, so you can put 1, 2, 3, 4, 5, just let me see, 1, 2, 3, 4, 5, 6, 1, 2, 3, 6. Okay, so this will match exactly one character. So there are other features like this. So I think for the complete list, you should either look online, or I'm not sure the textbook shows all that, but you can look online and see. So I just want to go through a few other things that you can do. So this next query, you show the effect of 10% raise in salary. So you can do select. Select F name, and then you can just say 1.1 multiplied by salary has raised salary. From employee. So it'll show you the effect of 10% raise. So you can just do, math right there. And so there are actually many features like this in SQL. I don't want to spend time in class. These are really easy. So if you get a query where you feel like you have to do something, and you think that it could be done easily by some kind of function, built-in function, just look online, and SQL has many built-in functions that you can use. So these were just a few of them. I'm trying to see. Yeah, I also want to show some with the null character, because unlike relational algebra, it doesn't really deal with null. SQL has the null, is really important. So now I'm doing from the textbook, I'm doing from chapter 6.3, 6.4, and chapter 7. So I want to show you the null character. So we have okay, so suppose the query is select employees that do not, or list employees that do not have a supervisor. So in relational algebra, where it doesn't really deal with null, this query would be, you'd have to use difference and stuff like that. But here, it's very easy to list the employees who do not have a supervisor, because you're listing employees where the supervisor's social security number is a null. So, and you can actually just write that down. So you can say select F name from employee. So you cannot say equal to null, you have to say is null. So in this case, you have listed employees who do not have a supervisor. And if I asked you to list employees that have a supervisor, then you can just say is not null. So, so you don't have to write a more complicated query to do this. And then, for example, this particular query, and again, as long as you understand that null is something is special. So for example, this next query, Okay, so if when you give this query, select star from works on where ours is greater than 10 or ours is less than 10. So if you go to the right side and you look at this works on table, this table has a total of 16 rows. 4, 5, 6. Yeah, so this table has a total of, there are 16 rows out here. But so you would think that if you gave something like where ours is greater than 10 or less than equal to 10, all 16 rows are going to be output, but that is not the case. It's not going to output this row which has null in there. So it'll only output 15 rows. So that's so you have to remember that that the it doesn't really work like standard data. So, or let's look at this next query, which is, kind of similar to this one that I just gave. So. Okay, and along with this, I add or p number is greater than 0. So now I've added an or condition out here. I've said where ours is less than 10 or p number is greater than 0. So now if you look at the output, look at the table out here, p number is greater than 0 in all of these rows. So for this particular query, the output is going to give you all 16 rows. So here you're going to have 16 rows, okay? But if I change this to, if I change this query slightly, so instead of saying or p number is greater than 0, I wrote down okay, so I have everything else is there. I just, instead of having this out here, I'm going to add this, and I'm going to add and p number is greater than 0. So now it's not an or. So in this case, the output will again not show this one. It'll only show, because now I have an and condition. So for an and condition, you know that both, for this to work out to be true, both this has to be true and this has to be true. Sorry. This has to be true and this has to be true. So in this case, when you have null out there, this is a false and this is a true. So the output would be false. So out here, the output would have 15 rows. Okay, so it is, it is a bit confusing because, null doesn't work like, so I just did this example for you to understand that null is not like, the other data. It's really just saying that you don't have the data right now or it hasn't been entered. So therefore, it works a bit differently. So does anyone have any questions?